Hi, I'm Alan Spears. I'm the Chief Engineer here at Rugged Marine. And if you're going to be looking at some of our Path Watch cameras, Path Scout, Path Recon, even some of our Night Chaser cameras, you probably noticed this MaXNight technology logo on all of them. And so you're probably asking yourself, what is MaXNight technology? So I thought I'd take just a couple of minutes here to tell you a little bit about how this technology works and why we use it. The flagship of our line, of course, is our MaXNight Path Watch camera. We have a RAM mount here. You can get all sorts of other types of mounts for it. This is on vessels all over the world, all sorts of different vessels, on police vehicles, on UTVs. It's used in lots of different industries, basically where you need to see without any other light source, without infrared light sources, without white light sources. This camera uses some image intensification basically to ramp up the light source, and we're also viewing in the near infrared spectrum, and the human eye cannot see very far into that spectrum, and this camera can. Basically, that's how we give you the types of pictures that we give you. In fact, let's take a look at some footage comparisons real quick between some of the camera types, and you'll see what I'm talking about. In this footage comparison, you see the thermal camera is the large picture here. It gives you a view that you don't get with any other type of camera. But as you noticed, it's not really high resolution. It's certainly not sharp and clear picture. It does have a lot of tactical advantage to it as well. But in the lower left, you see our MaXNight Path Watch camera. Look at what you can see with this camera without any other light source, just basically a little bit of moonlight, if you will, or a little bit of night sky radiance. We're utilizing an atmospheric phenomenon called night sky radiance, which is a lighting source not entirely in the visible spectrum. It emits 5 to 7 times more illumination than starlight. And this is not a starlight camera. If you're familiar with starlight cameras, they're basically slow shutter technology. They hold the shutter open for a tremendously long time, trying to gather in as much light as they can. And when you move, there's a lot of blurriness because that shutter is being held open. The camera on the right was the color day-night camera, and it was very dark. It's one of our best low-light cameras, 0.01 lux. But as you could tell, you really couldn't see anything but the basic light sources. They're all looking at the same scene in that footage. So we're tapping a light source that is larger than the visible spectrum. In other words, in bright sunlight, you have an irradiance, if you will, equal to about 1,000 watts per square meter. The way that breaks down is a little more than half of that spectrum is in the infrared portion of it. So we're dealing with the larger portion of light. A little bit less than half is the visible spectrum of it, and then you have a little bit left over that is actually the ultraviolet or UV spectrum of the light. We're straddling a wide range in the visible and infrared spectrum to give you the images with all of our MaXNight technology. It gives you a better image than any normal camera, and with sharper pictures and better resolution than the thermal that you saw, which much of this is outside of what the human eye can see. The entire infrared spectrum is really, really wide, and most people break it down into about 3 or 4 sections. You've got the near infrared, which is where our MaXNight technology works. You also have a lot of night vision devices, such as night vision goggles that work in the near infrared. And then you've got short wavelength infrared, which many military and other government installations use that type of camera, and if you price those things, they're really, really expensive. They also use that shortwave for long-range telecommunications as well. Both of those can kind of be lumped into the reflected infrared spectrum. Then you got the mid-wavelength and the far infrared. Basically, that's where thermal works. The thermal cameras work in this other end of the spectrum. In many ways, this technology can be better than thermal. Yes, we have to have a little bit of light, not very much to work with, but thermal has some tactical advantages. In fact, it can see warm objects on a cool background. This gives you a view that you really can't get anywhere else. But you can get more resolution and clarity with the MaXNight technology. In the military world, in other words, thermal can see a truck, but the MaXNight camera can actually tell you the difference. What kind of truck is it? Is it a civilian truck? Is it a military truck? You can actually tell the difference. Radar is much the same way. It tells you something is there, but it doesn't really tell you what is there. So basically we can put a longer lens on this, a shorter lens. You can get out to some of the ranges over a mile that you can get with some of the thermal cameras as well. So the advantages of the MaXNight technology: high resolution, high sensitivity, using our night glow or the night sky radiance light, the ability to use different lenses. We use some very high quality lenses here, such as megapixel lenses, and it's small size, as you can see, and low power consumption. And that's MaXNight technology from Rugged Marine. Thanks. I'm Alan Spears.